2 seconds. So first I am applying a force, 10 Newton force. So when I apply 10 Newton force, what conditions will arise? So you know background of these things, so don't bother. Now let's analyze in terms of work done idea. The first case, I'll starting the first case. F equal to how much it is? 10 Newton. You know what is the maximum force for no slipping? Already we have a formula, no? What is the background formula? The background formula for maximum force for no slipping is given by mu into m1 plus m2g. Mu is how much? 0.4, 2 plus 3 into 10. So this will be 20 Newton. So what is the force applied? Force is applied how much? 10 Newton. So will the friction force acting will be static or kinetic? Or no sir, I don't know formula. What is the best method? So directly I assume the friction force acting. So how the friction force on the block M2 like this, the friction force acting will be in the direction. I'll assume that no slipping occurs. Sir, how can you, how you can say, I too don't know, I'll work out. I don't know formula, I'll work out here. So what is the expression for this one? F minus F is equal to, or what is the net acceleration of system? The friction will become internal forces. So the acceleration of system will be F by M1 plus M2. 10 by 2 plus 3, 2 meter per second square. Okay, this is the acceleration. Then let's calculate the frictional force. F equal to M1A. This will be 2 into 2, 4 Newton. What is the limiting friction? Mu N1. Limiting friction equal to how much? 0.4 is 8 Newton, no? So, but how much we got? Less than limiting. So what you can conclude here? No slipping occurs between the blocks. This is the first basic idea. So no slipping occurs. So let's here bring the concept of two frames. One person P, another person, let it be Q. Now let's come for this. So what is the question asked? Find the work done by applied force for F acting on the block for T equals 0 to 2 seconds. So for 2 seconds, what is the acceleration of the block? We know. So can we calculate the displacement of the blocks as it is? So we'll work out all, even the work done by friction in different frames we'll see. So I'll enter into the problem. What is the displacement of the blocks? Displacement of the block is equal to AT square by 2. Acceleration is how much? 2. Time is asking how much time? 2 seconds. Will both the blocks will have same displacement? Yes, it is. So what is work done by applied force? So where this force is acting on the block M2, no? So shall we write this F into X? So what is the applied force? 10 into 4, 40 joules. So what is this? Work done by force F on block M2. Let's also work out the friction force. Now what is work done by the friction force? Work done by friction force. Who is doing this problem with respect to P? Now similarly with respect to P, what is work done by friction on the block M1? I'm splitting up this like this. So who will move the block M1? The friction force only. All of you able to see this? The friction force only. So what is the displacement of the block M2? That should be the displacement of block M1 because no slipping occurs. So what is the equation we are going to write it? F into X. And what is the friction force acting? 4 Newton. 4 into 4. 16 joules. This is what with respect to P, no? Look at this one. So what person P says? Friction does positive work on the block M1. Okay, that one. So person P, what is the comment? person P says that friction does positive work on block M1. Okay, got this. And what it says, and the same friction does negative work on the block M2. It just says that one. It does positive work on the block M1 and it does negative work on the block M2. So what person P again? Person P says that friction does negative work on block M2. I agree with this. Okay, let's come for the person Q. The same situation. Now let me bring the idea with respect to Q. No. What is the work done by the yeah, I think you are able to see the complete diagram. No. What is work done by the friction according to person Q? What is the person Q? What is the person P? Is the inertial frame, no? Person P is what? Inertial frame. What about person Q? Accelerating frame, non-inertial frame. Person Q, what he comments? Block is at rest. Person Q, what he says? Block is at rest. Block M1 is at rest. That's all, no? Then what is the work done by friction on the block M1? Account to him. Account to person Q will be zero, no? Any zero? Anybody? Why zero? Because there's no displacement of point of application of force. With respect to ground, the friction is acting and the displacement of point of application of force. Person Q, what's happened? He says friction is acting, but there's no displacement of block. Block is at rest. So what is work done by friction will be zero. You look at now the role of friction here. In frame P, in the ground frame, the friction does positive work on the block M1. In the block frame, the friction does zero work. So shall I say work done by a force depends on frame of reference. Getting the idea? So shall I conclude here? So look at the work done by friction. So what is the comment from person P? So what will be its comment? He said that person Q says that friction does zero work or no work done by the friction on the block. Better say no work here. No work done by friction on the block M1. So shall we conclude here now? Look at the P and Q. So what is a P? Person P is a, I'll write it too, because what they are different. Person P is what? Inertial frame. What about person Q? Person Q is a non-inertial frame. So shall we take this one? So therefore, what is the one very important point I'm going to conclude here? What is it? Work done is different in different frame of reference. In one frame, if a force does work, in other frame, need not to do that same work. It can be different, it's telling. Okay, you do get many problems here. So therefore now, definitely what happened? In a numerical, what you should make observation now? In the numerical, what you should make observation? You have to make observation, are there any different frames are there? This you may, this is what one example I took. Go back to this. So what is the state of M1, M2? Will they move with constant speed or variable speed? They'll move with a variable speed, no? Okay, got this. Okay, now come for stand on the ground. Stand on the ground. What is the work done by the normal contact? What is the work done by the normal contact N1 on the block M1? You say positive. You stand on the wedge and check it. What is the work done by normal contact N1 on the block? Will be zero. Because if you stand on the wedge, how the block will appear? It appears just moving down. So work done by normal contact N1 on the block M1 with respect to ground, positive and non-zero. With respect to wedge frame, it is zero. So I'm telling this one, if I want to ask any good question, no, I just take this diagram, I'll just ask you rather than find velocity of the block, I'll just ask you these things. So these you find very difficult because students got what happened, you are trained to what? Just write some equation, get an answer. There you find difficulty here. Go this the same. Go back to this problem only. Here only what pen? Wedge frame is there, and this one. You can also stand on the block and look at the wedge. It's not that wedge and block only. That one. There are three frames are there. What is that? The wedge frame moving horizontally, the block frame moving vertical, moving in a plane, and the ground frame. So in three frames, check it. What is the work done by the various forces? Will be different, and it just depends upon the values here. You have to. You can't say blindly. You have to work out and you have to tell it. Okay, I think so. Here is what slowly your difficulties will arise like this. So what is actually your focus will be work done by the various forces. So slowly I introduced to what today, the work done by the weight, work done by normal contact, work done by the tension, work done by the friction also. Okay, now there's the first case I brought it. Now second case, I'm going to apply 26 Newton. Second situation, F2 is equal to how much? The applied force is now 26 Newton. If I apply 26 Newton,